Our lesson today is solving equations with variables on both sides. We have not had variables on both sides yet. It's been just on one side and you solve in that way. So the first thing we're going to do is go through and talk about the key word. There's a definition here that we have not learned yet. Coefficient. So I'm going to give you an example of, we've learned this word. This word constant is just a plain old number, like a 8. Whoa, that doesn't even look like it. -7, whatever, just a plain number. But when we see math problems like, or it's not a problem, it's like an expression, like 2r, for example. We have r, we know that that's our variable, right? So could anybody guess what a coefficient might be? A constant is just a plain number. The variable is the alphabet letter. Yeah.
2 plain numbers? On both sides?
No, coefficient wouldn't be 2 plain numbers. Just looking at what I have there in red with my arrow, I've got the variable as r. What might the coefficient be?
The number.
The number that's attached. Perfect, both of you. So that would be the 2. So could you write, next to the word coefficient, write 2r and then circle the 2. The number attached to the variable. It's the number that's wearing a backpack. That's called the coefficient. And what we're going to practice today is getting variables together, getting the adding and subtracting coefficients together. All right, this is in our journal. Solve for the variable. Okay. Woo! Tricky, tricky. I made this difficult on purpose so we could work on it together. What is the thing that I distribute? I would not distribute the A. Try again.
45.
No, I don't distribute a 45. The minus sign.
Because in front of it's a 1.
Because there's like a 1. Can you please draw a 1 right after the negative and right before the parentheses? We don't put the 1s there because writing 1s all over the place is super redundant and unnecessary. Kind of like this equation starts out with an A. Yeah, if you wanted to put a 1 there, you sure could. If that helps you remember that it's a 1, then you need to do it. So, the only thing that I distribute is the -1. So that's like this. You're not going to touch the 1A in front at all. Leave it. So here we go. 1A stays. Okay, let's distribute. What is -1 times 6? Oh, 6A, sorry. -1 times 6A. -6A. What is -1 times 5? -5. Okay, good. I distributed. And then you just put equals 45. All right. Something else that we have not learned together, but let's talk about it now. On the left side, I have like terms. Right here. Put those together now before you do anything else. So it's basic. It's not 7. It's a 1. Take away a 6.
5.
What kind of 5? Negative. Let's do it in black because that's... I'll write my equation in black and like the steps and the tips in purple. Okay, -5A. Those got put together. Perfect. Then this -5 just drops down and you write it again. Equal sign just drops down. 45 stays, drops down. Okay. Now we're to what we've seen before. This is what we did on Tuesday. I want to get the constants, remember the numbers that are plain old numbers, together. How do I get, and let me do this 5 and this 45, the blue stars. How do I get those together? Add them together by doing what, both sides? Add 5, both sides.
Now it's like a regular puzzle.
Yep, it's just like the ones you've been doing. Guess I could put the other steps. Why not? It helps us understand, right? Distribute first. Combine like terms second. And then add 5 both sides. So negative 5a equals 50. Last thing. Get the a alone. Let's divide negative 5.
1.
Would be negative 10.
A equals negative, yeah, it would be negative 10. Perfect. Good. Our big main idea today is in order to get the variables together, the coefficients together, you need to move the smaller variable first. Okay? So can you please write that in your margin? Move the smaller variable first. And we're going to practice it. Okay, on number 1. So I have 2 variables to consider. I've got a 7x and I've got a negative 2x. The directions say collect the variable on the left side because it turns out that they're going to be on the left. Which variable is smaller, my purple 7x or my purple negative 2? Negative 2. I'm going to move the whole negative 2x together. Not just the 2. The x is going with it. Plus 2x. I am going to put plus 2x underneath negative 2x because then they cancel out to make 0. Right? 0. Nothing. And I can only add 2x to, it's like backpack. It's like term. 7x and 2x are like terms. I would not put the 2x with the 19. That doesn't work at all. I can't put an x with just a 19. No. What is 7x plus 2x? Variables together. 9x. Not 9x squared, just 9x. The 19 stays. The 55 stays. Ask questions as they arise. Let me know.
Wait, but it's plus 55.
Okay, positive. I wouldn't want to put like a plus sign in front of it because I already know it's positive. Question.
I thought you were to get both variables together.
You thought what?
I thought we were to get both variables together.
We did. Right here. We got the 7x and the 2x together. Now my job is to get the 19 and the 55 together. This is what we did on Tuesday. So plain old numbers. Woo! Positive 19. Moving it is what? Anyone? Feel free to help out. I don't want to hear the same people.
Minus 19.
I hear from you a lot. I hear from you a lot. Thank you. I love new voices. Okay. 9x. Oh, 55 take away 19. That's a whole like borrow from the 5, make it a 4, carry the 1. And my final step is divide 9. You are right.
That equals 4.
Okay. So I added 2x to both sides. I subtracted 19 to both sides. And then I divided by 9 both sides. Remember the whole goal of the lesson today? You wrote it in the margin. Move the smaller variable first. So on number 2, I'm not going to touch the 80. I'm going to focus on the variables. I'm going to move the smaller variable first. Which variable is smaller? A negative 9 or a positive 6? Which is smaller?
6. Or negative 9.
Negative 9. You're right. So add 9y. So what happens is the y's get to go together. And now, hey, I've collected my variables on the right side. 15y. Awesome. Okay, solve this with the people at your table. Finish it off. Figure out how you would divide it, and then you need to reduce that fraction. So we have to get the 15 over, but then you had to reduce this fraction. What number did you reduce 80 and 15? Like, what number goes into both? 5s. I heard someone say that, yeah. So I'm basically reducing 80 by 5, like divided by 5, and then 15 divided by 5. Okay, what was 80 divided by 5?
4.
Anyone do it yet? It's like this on the side of your paper. Divide it. 5 goes into 8. 16. How many times does 5 go into 15? 3. That can't reduce. We just leave it. Good. I'm jumping, and I'm going to have you guys to number 5. So go down to number 5. We're going to do 3 and 4 in a sec. Okay, you're going to do this with the people at your table. Step 1, all the way down to the end. Remember, talking, sharing, explaining, and move the smaller variable first. My choices are a -3 and a +6. So go ahead, as a group of 2 or 3s, go ahead. All right, everybody, yell out. What'd you do first?
-3 plus 3x on the front side.
Okay. All right, someone different. Tell me what you did next. Someone different. Thank you. And what was the answer?
1. That's easy.
Okay,
This is really easy.
you have. Same process, number 6, as a table.
Wait,
Go.
Can you go back?
Yes. Okay. Add 12W first. I know a lot of you were saying that. 12 is smaller, move it. Four plus 12.
16.
W, yeah. It does go in evenly.
4 times.
So you divide by 16 so that W is alone. 16 goes into 64 4 times, like you guys said. Okay, now I want to go back to number 3. Okay, can you guys distribute number 3 for me on the left? Go to number 3 and distribute the left side only. Okay. Huh? The left side is exactly the same as the right side. When that happens, what it means is I can plug in any number I want for x. I could plug in 2. 3 times 2 plus 6. 6 plus 6. 12 equals 12. I could plug in -73. Whatever number you plug in, you will always get the left side equal to the right side. Because right now, look at it. The equation, the left side equals the right side. When I plug in any number I want, that's called infinite solutions. Because if if it's the same on both sides, I can plug in any number I want for x, and I would get the left side equal to the right side. You can also say that I could plug in all real numbers. Any number that exists in the world is real. It's not fake. So all real numbers is another way to say it. Those two answers you would write down because I can't solve this math problem. I could plug in any number I want for x, all real numbers, infinite solutions, any number in the world I could plug in. So that would be the answer that you would write for a problem like this. If the left side is exactly equal to the right side, those are one of your answers. This one, infinite solutions or all real numbers. All real numbers also has an abbreviation. It's a capital R with a line down it. So that symbol, capital R with a line down it, means all real numbers. If you don't feel like writing ALLREAL, you could use the symbol instead. So that's number 3, when the left side equals the right side. Now let's look at 4. What's going to happen on number 4 is if I try to get the variables together by like moving one over, what would happen is that they would both cancel out. And now I have no variable. Oh, I can't solve this problem if I don't have a variable. If there is no variable, no, exactly. And so you would say no solution. You are exactly right. You should become a math teacher. Perfect. No variable, there's no solution. Your answer that you would write is no solution. You can't solve it if you don't have a variable. No variable, no solution. Good. So flip to the back side. Let's just talk about the ones I want you to do for classwork. You're not doing all the back side. You're going to do A, the first on the top, on both sides now. The first 2 A's, A and A, like, no, up above. Let me show you with the paper, actually, that might be better. All right.